asking since you said we can.
Yeah, you saying?
You said we can also. You said we can also write x is greater than -1 and less than 3. So does that mean that the first one we did is wrong,
No, it's correct.
or we can write both?
You don't
Or
write both.
oh,
You don't write both. Just write the one that we saw.
I mean, like you can write any of the two. That's what I mean.
No, thing is, memorandum has, the thing is, both of them are like the instances, for example, right? We're
Yeah.
gonna have to change the such a question, but in this case, we just write the one that we got. We said -2, right?
Mm-hmm.
Then we have x, and then we have 4 here, right? So we just leave it like this. We don't include the other one, and
Okay.
yeah. But I'll just try and remember. There was such a question where we needed to somehow, if I'm not mistaken, but it's fine.
Okay.
This is what we have here, right? And I hope everybody you're on the same. Let's say, and let's resume to 32, right? 3.3.2, right? They say if x is equal to 2, right? Calculate the sum to infinity. Sum to infinity, right? It's fine. So now we're given, so one, this is one of those questions, right? That if you got 3.3.1 incorrect, right? You can still continue the x is equal to that, and just put your x, right? So let's not be discouraged, right? But yeah, it's okay, fine, right? Let's just try and push everything and maximize. So let's resume, right? So here we have, so we just given x is equal to that, right? So for our sum to infinity, let's just write down the formula and see what we really, really need, right? So our sum to infinity formula says that it's what? Sum to infinity is equal to a over
1 minus r.
1 minus r, right? And one thing you should notice about the sum to infinity, right, is that it's 1 minus r always. It's never r minus 1, right? So this entails to us that we can only get a sum to infinity if indeed we have a convergent geometric sequence or series, I meant to say, right? R, right, is between -1 and 1, right? That's when we can truly have, right? Yeah, but it's fine. Okay, so here our value of a we do not have, but we know that we can replace x and get a, right? So let's just do some nice things. Right? So let's find T1. So we need a and r. Right? So r we can get it by finding the first two terms because so it's fine. Let's do T1. Yeah. Term 1. But okay, 3, right? Into our x now is 2. So we replace 2 minus 1, right? All squared.
It's 3.
That gives us 3, right? 2 minus 1 is 1. 1 squared is just 1, right? So it's just 3 over 1, which is 3, right? So yeah, if we have somebody confirming for us with a calculator, then we'll be fine. So now T2 is equals to 1 here. What do we have? Still have 1, right?
1.
Right. So here we have term 1 and term 2, right? So we can definitely find our R, right? So obviously our A is our T1, right? So we are sorted with that. Let's find R, right? So our R is equals to what? Term 2 over term 1, right? And then our term 2, we said it's 1, right? As we solve this, yeah. And then our first term is 3, right? So it's 1 over 3. That's our ratio, right? So that's our ratio.
For the term 1, why did we square?
For term 1.
Yes.
Because they give us this here, right? So it's 3.
Okay.
Right. So we just replaced
or previous question we found our r as x minus 1 over 3. We could have just substituted 2 with 2, and then we have 2 minus 1 over 3, which is 1 over 3.
Yeah, either or, right? Because remember, right, guys, we had our r, right? But our r that time was in terms of x. remember, right? We had this formula and we replaced our R here, right? You guys remember, right? And our R was in terms of X. So we could have taken that value that we got and replaced our X as 2, right? So yeah. So yeah. Let's cool. This push. Thank you, Chloe. All right. So our R is a third, right? And then let's just replace into the formula. So sum to infinity, right, is equals to our A. We got it as 3, right? All over 1 minus a third. Right.
It's 2, 3. 6 over 2, 3.
9 over 2.
9 over 2.
Right, 4,5, 9 over 2, right? And then yeah, we are clear, right? So we have 9 over 2 there. And then we are fresh, right? So the person who sent us this, right, please also send us the memorandum, right, in the group so we can see if we are on the correct path, right? And then yeah, not now, maybe after the meeting, it's okay. And then yeah, let's resume, right? So are we all on the same page with this question or anything you'd like to point out? Or
Can I ask something for clarity? So what Tlholo was saying is that we could what, replace Kokai?
Right. So let's just do it quick, ne? So remember we said our R, right? We used term 3 and term 2, right? So you say T3 over T2, right? So our term 3 was a third, right? Then we said divided by our second term, right? Which is 1 over X minus 1, right? And then we did our tips and times, 1 over 3 multiplied by X minus 1, right? Over 1. So we tipped this and then we changed division to multiplication. Right, so everybody gets that. And we got our X minus 1 over 3, right? So this was our R in terms of X, which we used to replace into this formula to find our possible values of X as we were asked in 331, right? So in this case, what Loki is saying, like, we could have replaced here our X. So our R is equals to our X, they said get 2, ne? So 2 minus 1 all over 3. And then we'll still get our R is a third. Are we on the same page?
Oh, yeah. Thank you.
Surely. All right. Yeah. So now we can move to the next paper that was sent. I think the next person who sent was great, right? So if we're all on the same page, the screenshot is, and then yeah. So now the meeting is recording, right? It's fine. So yeah, let's resume, right? And yeah. So let's start a new drawing. Okay, let's just select a photo. Are we flowing, guys? Are we flowing? Like genuinely, are we still flowing?
Yeah.
Yes, Mr. T.
Yeah.
Yes.
Mr. T. Mr. T. Mara. So did you see that?
I had to. So right. So here we have a 3-mark and a 4-mark question, right? And yeah, it's 2.2, right? So they say the first 3 terms of an arithmetic sequence are as follows, right? So we have 2y minus 1, so that's our first term. And then we have 4y minus 1, that's our second term. And we have 6y minus 1. That is our third term, right? As they say, we have 3 terms of an arithmetic. So arithmetic, what we have to understand is that our differences, this is so thick, right? So our difference
The same.
are the same, right? So our first differences are the same, right? Are identical, right? So they ask us, right? So they ask us to determine T30 in terms of Y. In terms of y. So this is very, very important. In terms of y. So rather, what we are not going to do in this step, right? As usually we would find the difference between this and find the difference between that, and therefore whatever we get, we equate it to that, because you understand that the first difference of an arithmetic sequence are equal, right? The first differences are equal, right?
Yes.
So now we can't do that, because if we do that, it's going to lead us to solving for y.
Yeah.
Are we together, guys?
Yeah.
The way I'm seeing it. This is how I'm interpreting the question, right?
Yeah. I agree.
Let's go back to yellow. Right? Are we
Yes, sir.
Yes.
right? So determine.
I was just saying yes.
All right, definitely, right? So let's push now. So determine T30 in terms of y, right? So whenever we have, let's just write down the formula here, right? This equals to a plus n minus 1, right? Multiplied by d, right? So don't forget the d, right? So I'd prefer us to put the d in brackets, because sometimes if we get a negative d, right, we'd be tempted to just put -3, for example, right? And minus. So the one. So
That's wrong.
so yeah, let me do. Yeah, so the first meeting has successfully been converted and it's been put together in a video. So yeah, so that one is ready. So just want to put some, some thumbnail, some to make it, but it's fine. So it's fine. And then yeah, so let's push. So here we have that, right? So what we need, right, is d, right, in terms of y, and our n, we have it in term 30, right? And our a in terms of y. You guys understand, right? So we need it in terms of y. So we do not solve for y in this case, right? So here, let's take it to the drawing board. Let's operate this one, right? So we know that to find our d, right, we take T2 minus T1, right? That's how we get our difference. Do we agree?
Yes.
So
Yes.
4y. So just want to take it to the left, right? Let's take it to the
Wait, how many marks? How many marks is this question?
3 marks.
Okay.
Right, so we take our D2 minus T1, right? So we can see there that our second term is 4y minus 1, 4y minus 1, minus in bracket, right? And then we can put 2y minus 1 here, right? That's our T1. So now let's operate, right? So we know that this is going to turn this into a negative, and this is going to turn this into a positive. So let's just write our answer same time, right? So 4y minus 2y, it's 2y. Right? So minus 1 plus 1.
0.
Cancels out, right? So this is our d. Our d is 2y. Do we agree?
Yes.
Right? And then we have our d. So we are sorted with our t. Our n, we have it as 30 because they want us to determine T30, right? And then we have our a, which is 2y minus, our a always represents the first term, right? So let's just replace. No one? So our T30, right? We have it as y minus 1, right? And then plus our n, 30, right? So it's 30 minus 1. Our d, we found it in terms of y, is 2y. Are we on the same page, guys?
Yes.
All right, so let's just solve for this, right? So let's just keep this as 2y minus 1 here, and then 30 minus 1 is 29. So 29 multiplied by 2y.
58y.
58y, right? And yeah, okay, so we have 58y there. So we see some like terms. One. So let's operate that one and find it in terms of y. So therefore, our T30, so let's just operate it here fully. Right, we can see that we have 2y and that 60y minus 1. Surely.
Just if it was if it was 1 mark, because I saw the answer just by observing. Because you can see that the first term there is 2y minus 1. We can see gore vele And then the second term is 4y minus 1. Third is 6y minus 1. You can see it's b minus 1 minus 1 minus 1. And then with the 2y, 4y, 6y, it's like 1 times 2. And then the second term, 2 times 2. And then third term, 3 times 2. So for the 30th term, it will be 3 times 2 minus 1.
Times 2.
If it was 1 mark.
Definitely, all right? 30 times 2, we can see that here. This is our T1, right? And as we can see that the coefficient of y here, what our first term, right? It's 2. So we took 1, which is our term, and then we multiplied by 2 to get the coefficient of y here, right? And then for this, you understand? So that's by observation, right? So you can just observe it, right? And already have your answer in head, right? But because of the marks, we still need to work it out, right? Because it was also important to check the mark allocation, right? Thank you so much. Thank you so much, Robin. So yeah.
Thank you,
So yeah.
Sure.
So we solved 2.2.1, right? So I believe this step is necessary in some way. You can just put it and squeeze it in, right? Somewhere, somehow. One, that's fine.
Yeah.
So let's move to 2.2.2, right? This is a 4-mark question. And then they say, determine the value of y, given that the sum of the first 30 terms of this sequence is minus 2, 8, 2, 0. Right? So let's just write down. Okay.
Yeah.
Let's say it's telling us that S30, right, is equals to negative 2, 8, 20, right? And then they want us to therefore determine the value of y. So this is an arithmetic sequence, right? So I just want us to write down the sum formula of arithmetic. I want to see something, right?
Yes.
It's fine, right? It's okay. So it's the Sn, right, is equals to n over 2. Please correct me if I may skip something. 2a plus
n minus 1.
I like putting the d in brackets. So the d is very important, guys, right? So let's put it in brackets. Right? No pun intended. Okay, so let's push, right? So here we can see that our n, right, we can have that because we're looking at the sum of the first 30, right?
Yes.
And our a looking for the value of y, right? But we're not looking for it in our normal way, right? We would just find the difference and then equate it, right? So they want us to find it in a way where we say that the sum of the first 30 terms of this sequence is negative 2, 8, 20, right? So we're going to need to use the sum formula, right? So we have S30, that's the information that they've given us. Hold on. Right. So what we're seeing here is that if we're going to be using this sum formula, right, obviously our Sn here, we're going to put this negative 2, 8, 20 here, right, and equate it to the rest of the formula. So now we're looking at what we can get, what variables we already have. So here we just agree that our n is going to come from this 30 here, and then our a, remember we wrote our right, so it's 2y minus 1 there, right? And then our n is still 30, and our d, remember we said it's 2y.
Yes.
So we can navigate around that, and then our only unknown is going to be y, right? So if we replace everything, right? Right. So yeah, let's push, right? So now we know that our Sn, right, negative 2, 8, 20. All right, and also, right, I think we can also use our normal way in which we would have found it naturally to see if the answers match. But it's fine. Let's continue. So our n, right, what is the sum of the first 30? So this negative 2, 8, 20 represents the sum of the first 30 terms. So our n is indeed 30 over 2, right? Into 2. Our a, remember, they've given us 2y minus 1. Just write it like that. And then plus our n is 30, right? 30 minus 1. Right? And then our d, remember, I get 2y. So this is what we have here, right? And then here, 30 over 2 is 15, I got. So let's just try and simplify that.
That's minus
Right,
2.
okay. So 2 into that and 2 into that, one. So we have 4y minus 2y, right?
Yes.
This is 30 minus 1 is 20.
4
Yeah.
minus 2.
Not minus
So
12.
minus 2, so
Minus 2.
Minus 2, right? Okay. Thank you so much, guys. So it's minus 2, right?
sure.
And then in the brackets, we have 30 minus 1, right? So 30 minus 1 is 29. So 29 multiplied by 2i, we've done this somewhere. We have it somewhere here.
Yeah,
58.
yeah.
And then we have plus
58y.
58. Right? And then, yeah, we can see some similarities, right? And we still have negative 2, 8, 20, right? So most times, right, whenever you have this here, right, we do not advise that you multiply throughout, though you can, right? But we can see that also on the left-hand side of the bracket. If it's possible, let's try on our calculator. Let's try and say negative 2, 8, 20 divided by 15 to see if it gives us something that's not a fraction, and, you know, let's see if it does solve that.
Yeah, it gives us a proper number.
It gives us a proper number. So we can, therefore, instead of multiplying the 15 throughout, divide both sides by 15, right? Let's divide both sides by 15, right? The reason why it's legal for us to cancel out, right? Even though there are plus and minuses in the bracket, because this simply means 15 times. So in this case, this is one term. This is one term, right? So yeah, it's one term, right? So it's just one term. Then we can just cancel out this 15, right? And then obviously what we do on the left, we do on the right, right? And then we have, that is negative 188. I got that. What do you guys get?
Got the same.
Right.
Got
So
the
of course
same.
we have. So now we don't have to rewrite this 4y and stuff, right? Because we can see that we have a like term, right? So 4y plus 58y, right? So we have
Yes, Mr. 2.
minus 2, right? And then now the rest is history, right? So we can just take it to the other side. So now plus 2, what do we get?
It's a 186.
186.
Right, is equals to 52. Wow. So thing is, these things are they are corresponding, man. Look at the answer that you get. Wow, you understand?
Yeah.
You know, so we're not that far off, right? That's fine. So we got our y is negative what, ne? So they say determine the value of y in terms of the sum what. So let us do our own formula on the side just to confirm, to support this answer, right? Right, so let's just do it. So how we usually do it, right? We know that T1 minus T2, okay, let's just write it here, right? T2 minus T1 is equals to T3 minus T2, right? So our second term is 4y minus 1, right? So 4y minus 1 minus the other one, right? So we're going to get 2y, ne?
Yes.
Wait, let's write it. I want to see something, right? Let's write it. So it's 4y minus 1, right? Minus in brackets is 2y minus 1. 1 is equal to our. See something if we were going to be able to solve for it, right? Okay, let's see 6y minus 1, and then our T2 is 9 minus 4y minus 1. Wow. So the thing is, we want to get 2y is equals to 2y. That's the thing.
2 equals to 2y. Exactly.
So there was that. There was no way, no way forward in this one. So it's fine.
Yeah.
So we needed such information to be able to solve it on our own, right? But it's fine. So are we all on the same page, family?
Yes.
100, man, 100.
Right. So the screenshot is, it's your time to shine, and yeah. So yeah, I believe we're done with this question, right? And I believe that we all understand. And the person who also sent us this question, please send the memorandum in the group to see if we're on the same page, right? And then so we can move to the next one, right? If we are all on the same page, or any questions from the family?
Nope.
Yeah, so we have about 9 minutes 50 seconds left of this meeting, right? So we can just begin maybe the first part of the next batch of questions, and then we continue there further after, right? So new drawing, and then we can select photo. Right, and we did that. So let's go to this one, right? We have this one. So they say, given a geometric sequence, right? So geometric sequence, right? We understand that there's a common ratio between the terms, consecutive terms, right? Use color, right? So so they say this is a geometric, right? So we understand there's a value of r, right? Our ratio, right, which is constant. So they ask us to determine the value of r. Are we together, guys? Can you guys hear me? Am I audible?
Yes.
100.
All right, so they say determine the value of r, the common ratio. So this is 1 mark, right? So r, we know that r is equals to what? T2 over T1. Favorite number, you can just write T3 over T2, and then you'll include your 9 there. One. And then let's push. So we have negative 18 over 36. So somebody, we get you?
Is it negative 1 over 2?
Yes, right? Negative half, right? And then, okay, so let's move to 222, right? Calculate n, right? If Tn is equal to 9 over 1 whatnot. So Tn, right? So let's just write the formula. So Tn always represents the formula. So for a geometric, right, what's our formula?
AR n minus 1 to the power of n minus 1.
Minus 1, right? So this is our formula, just like that, right? And then now they want us to calculate the value of n, right? So the value of n is the position, right? So if our Tn is equal to 9 over 4k and 96, right? Let's see, right, what our value of n is, right? And here, Tn, right, we're just going to replace it as they've given us there. So they said 9 over 1, 0. Sorry about that. So it's 40. Thank you, sir. Right, 4096. Our value of a, right, is the first term. So there we have it as 36, right? So you can put it in the brackets if you like. So let's just put in brackets for this one. And our value of r, which calculated in the previous question, right? It's negative 1 over 2, right? And all that to the power of n, which is unknown, which is what we're looking for, minus 1. So here we are good. It's good to see that we only have one unknown, right? So we can interpret like proximity, right? Let's push. So here we can see that we're looking for right. So looking for n. So I want to get closer and closer to n, right? So the things that are disrupting n on the right hand side. So there's this 36. Let's remove that before we dilute the negative half, right? So here it's multiplying, right? So let's divide both sides by 36, right? And all this divided by 36, right? And then what do we have? Negative 1 over 2 to the power of n minus 1. Somebody please help us.
Is that 4096?
Yes, 4096.
Wow,
Yes.
the answer is 1 over
16384.
84, right? 16384, right? So that's what we have there, right? And then they say that is equal to, and all right. It's not a problem, right? So now, is it possible to find So like, yeah, one thing about the calculator, we can't just put this in the calculator and press shift and whatnot. So we know that.
Sorry.
Yes.
Sorry, guys. If anyone here now knows how to do the fact, like let's say we have this value and we want the exponential form of it. Does anyone know how to punch that in the calculator?
Yeah.
That's what Tapolo was explaining about
Thing
to
is, I
explain.
can do it on the screen. Yeah? I can do it on the screen.
Okay.
I have a calculator app, right? But yeah, but since we haven't done yet a lot, so even if it drops everything, it's not a problem. Yeah? So let's try. Let me just go do it on the app, and then we. So the app is calculate something. Yeah. So this is the app, right? And now, please give me the number. Somebody, if anyone wrote them down, please give us. So we had 1/163.84.
163.84.
Right. And one thing about the calculator, right? 163.84. Right. One thing about the calculator, right? You can press equals and then you press shift fact, and then it gives you as 1 over and whatnot, right? So let me just show an example. So yeah, my shift is on. I press shift and then I'm gonna press fact. Right. So this one does give us, right, in terms of this. But on your casual calculator, you just try and press the fraction 1/6, 163.84.
That's error.
Shift fact, right? So we can wrapper this. Let's use the denominator alone. Look at this. 163.84 equals to shift. We press fact. It gives us 2 to the power 14. Right? So that's where we can wrapper it, because we can also write it as. So now we can change that. Right. So this name is going to be written as 1/2 all to the power of 14. Right? Because we know that this doesn't get affected by the exponent because it's 1. And then this will also get a thing, right? So the only thing that I'm looking at, right, is this -1/2 that we have here. You see we have a -1/2 there.
Yeah.
Right. So, and I think, and then one thing, right, we noticed that our exponent is even. Right. So we can still write it in that form. Look at this. We can still write this as 1/2, -1/2, if we like, to the power of 14. Somebody please doing it, because our exponent is positive, that negative will be a positive. You understand? So it will still give us this as a product, right? So let's try. Right?
It's the one. It's correct.
Is the one, right? Is the one. Okay. It's fine. It's fine. It's fine. It's fine. Let's push. Right? It's okay. And then we have is equals to -1/2. Right. So the meeting's gonna end in just under 2 minutes. So n-1. Let's see if we can squeeze this one in, right? So now our bases are equal. Then we equate the exponents. 14/2 and -1, right? So our n is equal to the square root of 225, right? Square root of 225, right? It's 5.
Yes.
Okay, and yeah, so we have that. Do we understand, guys, how we write to this?
And
Hope we are flowing, right? And after we want to calculate sum to infinity, we have our value of r, we have a, right? So yeah. So the meeting is about
before screen recording. It's okay.
Okay, right. So yeah, if you like to screenshot, this is the opportunity. And then yeah, okay, looking forward to the last question there. It's fine. Okay, it's fine. All right. And yeah. So that's what we have for this session, right? So we have less than a minute left. So I'm just gonna manually end the meeting, and then same time we just join, right?